PhD in rotorcraft dynamics. He has evolved to become really an AI evangelist in this industry. And he will now take us on a ride into the ML-enhanced aircraft maintenance business.
Thank you very much. Very good afternoon to everybody. From protein biology to aircraft, I think there's a huge jump. Today, my talk right now shall be more about an use case. So I'm from the Institute of Maintenance, aircraft maintenance specifically, and this shall be about aircraft maintenance. And I shall be also talking, I joined the project only a few months ago, and right now I only have the architecture, and the reason for me presenting it here is so that I could get some feedback from any of you who has some experience in this field. So without further ado, jumping into the domain. So aircraft maintenance is a very mission critical domain where safety, precision, and compliance are very have very high priorities. So the primary goal of MRO, the maintenance, repair, overhaul industry, is to minimize the downtime. Downtime being the amount of time that the aircraft spends on the ground. So every second that the aircraft spends on the ground means it's not making money for the airline, so that's a loss. So primary goal is to minimize the downtime while ensuring that the airworthiness are met, and along with the compliance with the industry standards. Now, aircraft maintenance life cycle has several kinds of maintenance, right from line maintenance, A check, so-called A check and B check, which happen sometimes after every flight or every few days, to hangar maintenance, C check and D check, which are much more involved. They happen. C check happens once in 1 or 2 years, while D check is once in 6 years or so, where the entire aircraft is disassembled and then reassembled afterwards. And then there are also unscheduled maintenance, which is a nightmare for any airline business. Now, the key thing to remember with all these maintenance is that, as per rules, every visit to the hangar, every maintenance task, work which has been done, has to be documented, and it has to be stored. So in the life cycle of an aircraft, that will be a huge amount of text data. And if an airline has multiple aircrafts, again, that runs into multiple huge data. And it's the maintenance teams, they have to handle complex procedures, and also have to look into all this vast documentation, while also looking into all the regulatory requirements. So not only if it is in Europe, not only within Europe, but also in other continents. So these documentation resources are very important because they establish the systematic protocols for any defect identification, right up to their logging, analysis, rectification, and certification. Now, the aircraft industry, unlike most other industries, is quite slow when it comes to adopting new technologies, and similarly, even the digitization is also it's very slow in the industry, but it's happening now. And when all this documentation is digitized, these integrate the documents into a central system, and this will ensure streamlined workflows, regulatory compliance, and also it enables predictive analytics. So how do we do predictive analytics? There are primarily two paths which ensure, or two kinds of data set which ensure, which aid in predictive analytics. One is the real-time, all the data which comes from the sensors on the aircraft, which I will not be talking about. The other set of data is what I just mentioned, which is the huge amount of text data in the form of maintenance reports and the manuals and so on. And with the advent of all these new recent AI innovations like the LLMs, the RAG and knowledge graphs, the operational resilience of aircraft maintenance workflows can be improved. Let me speak a little bit more about these. As you know, the LLMs today have kind of become a backbone to a lot of these AI-powered tools that are coming up these days, whether they be virtual assistants or complex data analysis tools. Now, in spite of the awesome capabilities of these large language models, we know that they do have certain weaknesses. for example, outdated knowledge base and the resulting hallucinations, for example. The OpenAI suggests this graph here to aid in optimizing LLM performance. So they suggest that one could start right from the left bottom corner, which is a prompt engineering, and depending upon whether one wants the model to be improved, one could do the fine tuning, or whether one wants to improve the knowledge base of the model, one could go along RAG, and if one wants both of them, then we could take in all these methods. In our case, as I mentioned earlier, the LLM is trained originally on the generic corpora, which is the internet-related literature. It's not trained on aircraft maintenance documentation, which is why we need to adopt the technique of RAG. So what is RAG? RAG stands for Retrieve, Augmentation, and Generation. And we see here what happens is it involves the ingestion of a lot of domain-related documents, which is chunked into smaller pieces, and then in the process called embedding model, it's vectorized and indexed. Now, when a user gives a query, the same process takes place. It's also the embeddings of this query are created, and then the vector resulting from this query is compared. A similarity search is done for this vector with the most relevant text, and that is retrieved. Model where it generates the response to the user. Now, this improves the hallucination part a lot. Also because it improves the knowledge base of the language model. But however, even with RAG, there are still some weaknesses. The main being that the contextual understanding of what is being retrieved from the database is not strong enough as we would want it today. So what is the solution? Solution to this, one of the solutions to this is the ontology and knowledge graphs. So ontologies form the semantic backbone of advanced AI systems. They give the formal definitions of concepts, properties, relationships, and rules. So in the case of an aircraft, the concepts would be any of the classes, like the component, the engines, or any of the maintenance procedures. Each of these would have their own properties, and then relationships would be something like an engine belongs to the aircraft. It's not the other way around. And there could be rules like a particular aircraft could have 2 engines or 4 engines and not more than that, or the engine cannot be of a larger size than the aircraft, and so on. So these ontologies are actually blueprints for knowledge graphs, which is what we would want. So once we have the ontologies, the knowledge graphs are created from these frameworks into actionable data structures. This is a sample of a very small part of the knowledge graph of a Sikorsky S-92 helicopter. We can see that the helicopter has its main sub systems like the power plant, avionic systems, and so on. The main rotor subsystem has a relationship with the rotor vibration analysis, as in it's being monitored via this analysis method, and so on. So that's an example of knowledge graph. So once knowledge graph along with the original RAG can be used, and the LLM can be used to create. I'm sorry. Let me get back. I think I'm running ahead of myself. As we already mentioned, RAG retrieves relevant documents to augment large language model responses, but it has a limitation that the contextual understanding of documents is missing. For example, RAG may miss relationship between maintenance procedures and their dependencies. So knowledge graphs make up for this lack by interconnecting entities and capturing relationships. And combination of knowledge graph and RAG, which can be called as a graph RAG, can better comprehend the context of the user queries and reduce hallucinations. And yeah, so using the combination of the language model, the RAG, the knowledge graphs, one application that could be built is a virtual assistant. So here is a mock-up of a application that we foresee. It's a aircraft maintenance assistant, which could be very useful to the maintenance teams on the ground who originally have to refer to a large number of documents. So this could easily answer their queries in a few seconds rather than them looking into the documentation for, I don't know, multiple hours or even multiple days. But of course, there are challenges, and some considerations are that, of course, for any domain, this is not only applicable only to aircraft maintenance. It can be, of course, it is transferable to multiple domains. The main challenge is it requires significant domain expertise and data integration efforts. It's not an easy task building these knowledge graphs, and there should be a mechanism to update these knowledge graphs continuously. And of course, when building a virtual assistant, the user interface must align with the technician's workflow. And of course, we need to verify that the maintenance recommendations output by the virtual assistants are true. So that I'll end my talk, and I'm open to any comments or suggestions or questions. Thank you.
Thank you. If you have questions from the audience, then please come to the microphones. I have a question. Obviously some aircraft types are used or more popular than others, right? So how does this affect this whole system? Because I mean, for some you will have maybe better ontologies or more ontologies. You will have also more maintenance sheets. How does it scale, basically?
Ontology is something that we need to build. As on today, there are no ontologies available for any aircraft. This is something we need to build ourselves. So in terms of effort, I don't.
So one quick question. So regarding the building of ontologies, are there approaches to use large language models to help you assisting building ontologies? And if yes, how would you compare if different language models build different ontologies and then you want to compare the quality of these ontologies? Is there measure to compare them?
You mean building an ontology with the help of a language model? Yes. Yeah, that's a state of the, I would say that's a state of the art. So as on today, we are still looking into whether the creation, it's not, ontology is actually an intermediate step to building knowledge graphs. So knowledge graph is what would be actually usable. The ontologies are like I said, they are just blueprints. So as far as building knowledge graphs is concerned, so one of the research topics that a student of mine would be taking up soon would be automatic building up of these knowledge graphs with the help of language model, yes. But of course, in spite of that, I still see some amount of human intervention. Later, maybe 70–80% can be done. The bulk work can be taken up can be automated, and the rest 20% can be taken up by humans.
Yep. Thank you.
Thank you for your talk. Just one quick question. How do you plan on retrieving relevant context from the knowledge graph given the query of a user? So you have your knowledge graph and you have a query of the user. How do you identify or retrieve the relevant context to that query from your knowledge graph?
Relevant context. So knowledge graph contains the relationships between the different entities. In this case, let's say the aircraft is the subject. So the knowledge graph includes the relevant relationship between different entities. And so it aids the language model in getting the context. Without the knowledge graph, the language model cannot really, it doesn't really understand what it is actually giving as a response. it has done some similarity search between the query vector and the vectors available in the database, and then given the one which is the closest to that, but it doesn't understand the context at all. The knowledge graph helps the language model get a context.
Okay. So you're planning to encode each node of the knowledge graph so you can make similarity search?
Right. It's still very unclear for me, but it will be, knowledge graph would be in the form of a graph. And traversing a graph is much, having it in the form of graph is also quite useful, because traversing a graph is much faster and easier for the language models.
Okay. Thank you very much.
Thank you.
So some simple question here. So interesting topic. Also, I'm working on the ontology and knowledge graph. So the idea now, you will index this knowledge graph, right? Like triples, SPO, and then you will use these embeddings. What kind of, can you comment on what kinds of embeddings there available?
I cannot answer that question yet. I have not gone that far yet.
All right.
We are still in the process of building the knowledge graph as on today.
All right. Maybe we can talk later.
Yeah.
Okay. Thank you.
All right. Then let's move on to the spotlight.